Right, so let's start with this EMFT tutorial 2. In that, I'm going to solve one of the example based on the concept that we have studied yesterday, that is Coulomb's law. Right, so I hope everyone is now clear with Coulomb's law, how we can find out the force between two charges. Right, so basically the force is directly proportional to product of those two charges, magnitude of charges, and it's inversely proportional to square of distance between them. Then we have identified two formulae based on Coulomb's law, right? So for first case, if this is q1 and this is q2, this is q1 and this is q2, right? So this is the distance, and we are trying to find the force on q2 because of q1. In that case, we define this vector r12, vector r12, and we can write f12 bar is equal to, which is actually a force acting on q2 because of q1, which is equal to q1 q2 upon 4 pi epsilon naught r12 square. This is magnitude a bar r12, a bar r12. And if I try to find the force on q1 because of q2, in that case, you have to reverse the direction of everything. Like subscript would be r21, f21, a bar r21, likewise. Right? So this is the only difference that we must understand. You must identify the force in which force on which the charge on which the force is being calculated. This is important to know, right? So let's begin. Two-point charges. If you are ready with pen and paper, you can note down the example. I told you example will be written in blue lines, blue color. Two-point charges. Here is the example. Two-point charges. Two-point charges. Q1 equal to 50 microcoulomb. Q1 equal to, this is Q1 equal to 50 microcoulomb, and Q2 equal to, and Q2 equals to 10 microcoulomb, 10 microcoulomb are located at -1, comma 1, comma -3 meters, -3 meters. If meter is not given, by default it's meter, and 3, 1, 3, 1, 0, 3, 1, 0, respectively. Means what? Q1 is located here and Q2 is located here. That is the meaning of respectively. Find the force on Q1. So the problem is find force on Q1. Find the force on Q1. See, you are having Q1 located somewhere here, right? So let us solve. Let us try to solve this example. Right. So let's assume Q1 is located here, and we know the coordinates of Q1. What are the coordinates of Q1? It's -1, 1, -3. And you are having Q2 located here at location 3, 1, 0. So we have written 3 steps. What are 3 steps? Step 1 is to find the vector. Which vector? This vector. because we want to find the force on q1 because of q2. So this would be the direction of vector. So this vector could be r21, r21 bar. So find the vector. Sorry, step 1 is to draw a neat picture. So I have already done. Step 2 is find the vector. Step 2 is find this vector r21, right? So in step 2, r21 bar is equal to this, you have to find. Then you have to find the magnitude of r21, which is required to put in Coulomb's law. Then you have to find unit vector in that direction, a bar r21. Once you get all those things, you can go for step 3, that is use of Coulomb's law. In that case, F21 bar, that is the force on Q1, is equal to value of Q1, value of Q2 divided by 4 pi epsilon naught R21 square, sorry, R21 magnitude of this square into a bar R21. So these are the steps that you have to follow in order to solve this example. So I hope everyone is ready with pen and paper. Start solving this example and try to tell the answers to me, so that I will get to know that you are following the correct steps or not. By the time I'll check the attendance. Roll number 22. 22. Roll number 32. 32. 36. Roll number 36. Roll number 40. Roll number 40. Roll number 43. 46. 47. 48. Roll number 51. ठीक है. Let me repeat. Roll number 22, 32, 36, 40, 43, 46, 47, 48, 51. See, most of those students are frequently absent, and to them I have a message. So if some of them are your friends, please pass on my message to them. Most probably the examination would be conducted offline. This is message 1. Just a minute. What is your the message one? Message one is most probably this lecture, this examination, university examination would be conducted offline. And second thing, if the examination of EMFT is conducted offline, and if you don't attend the classes, you will not be able to get passed in this examination. You will shortly realize the difficulty level of this subject. In the first lecture itself, I tried to make you aware. थोडक्यात सांगायचं झालं तर जर लेक्चर्स नाही अटेंड केले तर ब्रह्मदेव जरी आला तरी हा सब्जेक्ट सुटणार नाही. आणि एकदा सांगतो मी की तुम्ही रेग्युलर क्लासेसमध्ये अंडरस्टँडिंग थोडं इमॅजिनेशन वाढवत गेला तर काहीच डिफिकल्टी येत नाही. पण एकदा सुरुवातीचे रेग्युलर लेक्चर्स जर मिस करून जर परत विचार केला की बाबा चला जर ऑफलाईन झाली तर सब्जेक्ट राहिला तर परत काढूयात, जोपर्यंत तुम्ही ह्या क्लासचे रेग्युलर लेक्चर्स तुम्ही अटेंड करत नाही तोपर्यंत तुमचा हा सब्जेक्ट क्लिअर होत नाही. कीप इट इन माइंड. आय कॅन टेल यू सम ऑफ द एक्झाम्पल्स. म्हणजे बीईत गेलेत, EMFT बॅक लागलाय, बीईचे क्लासेस, बीईचे रेग्युलर सब्जेक्ट बंक करून EMFTच्या क्लासला बसायचे. I can give you such examples. मग ही जर भविष्यात येणार असेल वेळ तर यूज देऊ नका ना, आत्ताच क्लासेस अटेंड करा. Pass on this message to those who are not attending. If it's going to be offline, if you are frequently absent, then माझ्याकडून तुम्ही हार्ड कॉपी मध्ये म्हणजे माझ्याकडून साइन करून घेऊन जाऊ शकता की तो सब्जेक्ट निघणार नाही तुमचा. ठीक आहे. सो आय होप यू हॅव सॉल्व्ड दिस. सॉल्व्ह केलं असेल. हे केलंय कोणी? हा वेक्टर काढा पहिल्यांदा. वेक्टर काय R21 काय आलाय सांगता येईल कोणाला? व्हॉट इज दिस वेक्टर? बघा आपण जस्ट एम आय ऑडिबल? हॅलो. Okay. See, what we are doing here is end coordinates we are subtracting. So 3 minus of minus 1. Right? So 3 minus of minus 1. Right? So a bar x plus 1 minus of minus 1. Sorry, 1 minus 1. 1 minus 1. A bar y. Then plus 0 minus 3 a bar z. Right? So what would be the answer? What is the answer? Can someone tell? सोडवलंय कोणी? Is there anyone from class?
Sir, it will be 0 minus of minus 3, na?
Which one?
That a bar z.
0
Minus of minus 3.
yes. It will be 0 minus of minus 3. Correct. Minus of minus 3. Yes. So how it will be?
4 a bar x plus 3 a bar z.
Correct. So it would be 4 a bar x plus 3 a bar z. Correct. Now here under root 4 square plus 3 square, right? So this is going to be 4 square plus 3 square. So what is the answer? 5. Am I correct?
Yes, sir.
And here it will be 4 a bar x, right? plus 3 a bar y, sorry, 3 a bar z divided by 5. Is it correct? Because unit vector is vector upon magnitude. Magnitude is 5. Vector is 4 a bar x plus 3 a bar z. So this is equal to. Now put on the values. All the values have to be inserted here. I told you if it is micro coulomb, then 10 raised to minus 6, right? So put here the value of Q1. Value of Q1 is 50 microcoulomb. 50 microcoulomb means 50 into 10 raised to minus 6 into Q2. Value of Q2 is 10 microcoulomb. 10 microcoulomb means 10 into 10 raised to minus 6 divided by 4 pi as it is epsilon naught. Value of epsilon naught is 10 raised to minus 9. I told you this constant yesterday, upon 36 pi, right? So this is the constant, or you can say permittivity for free space, right? So epsilon naught, value of epsilon naught is 10 raised to minus 9 upon 36 pi into 5 square. Stop me if I'm wrong. Into 5 a bar x plus 3 a bar y divided by 5. Now it's your turn to calculate this thing. You first of all calculate this one.
So it's 4 a bar x.
Which one?
That unit.
Yeah. It's 4 a bar x. By mistake, I have written 5. So this way, attentiveness is very, very important. If I make any mistake, you should be able to catch. Right. So first of all, I hope you will calculate this one, this part. Then you need to calculate this part also. You consider this denominator of this 5 you consider here and get it calculated. So you will have only this vector remains. And tell me the constant that you get here, or you can say a multiplier. See, I want this term divided by this term and the final value here. In this bracket. Here I am going to write 4 a bar x. It would be as it is 4 a bar x plus 3 a bar y. So tell me this bracket value. Can anyone from the class could find out this?
So I got 0.16.
0.16. 0.16, right? So can you multiply this inside this and check whether you are getting this answer? Because I have a direct answer. You can use it as for cross checking. So check once you multiply this inside, check whether you are getting this 0.144 a bar x plus 0.108 a bar z. That has to be a bar z. Why nobody is telling this? This has to be a bar z. Are you getting this answer? Are you getting this answer?
सर ऍक्च्युली तिथं 0.16 नाही येत 0.036 येते देन आन्सर असं येते
किती यायला पाहिजे
0.036
0.036. Okay, make it correct. Somebody said 0.16. 0.036. Check it out now. So this is the final answer. Are you getting this?
येस सर
Okay, so let's move ahead to understand next concept. And so this evaluation we have done for point form of charges. Like if the charge is present in point form, then and only then we can find out the force, or let's say what you can say force, or you can say other electric field intensity, etc. Right? So just to revise what we have seen as of now. See, if you are having a test charge, if you are having a test charge, let's say QT here, and if you are having some source charge here, QS, right? So this QS will have its lines of forces present over here, right? So these will be the lines of forces, and we will call it as a field. We will call it as an electric field, right? And because of this electric field, some force gets applied on this test charge, and that force we can calculate by using Coulomb's law. We can calculate using Coulomb's law. But what will happen if the source charge is having some different configuration, such as let's say, if you are having a line charge. Line charge means what? All those charges are placed in a line. They are uniformly distributed. एका चार्ज मुळे तुम्ही फोर्स काढला. आत्ताच आपण एक एक्झाम्पल सॉल्व्ह केलं. जर अशी लाईन चार्ज असेल तर काय करणार? किंवा दुसरा, दिस इज व्हॉट कॉल्ड एज लाईन चार्ज कॉन्फिगरेशन. Suppose if you are having a surface, on that surface the charges are distributed uniformly, and because of those charges, how you can find out the electric field intensity on test charge? Or suppose you are having a volume. If you are having a volume in which the charges are uniformly distributed, in that case, how will you calculate the force on this QT? So this is going to be your surface charge or sheet charge. This is going to be your volume charge. ठीक आहे. पॉइंट चार्ज जर असेल, जसं आत्ताच सांगितलं मी, QS म्हणजे सोर्स चार्ज असेल, तर हा फोर्स तुम्ही लगेच काढू शकता बाय युजिंग कुलोम्स लॉ. बट जर लाईन चार्ज असेल किंवा सरफेस चार्ज असेल किंवा व्हॉल्यूम चार्ज असेल, तर त्या केसमध्ये फोर्स कसा कॅल्क्युलेट करणार? अँड हेन्स देर इज अ नीड टू अंडरस्टँड दोज there is a need to understand the concept called as charge configurations. Are you getting what I said? Coulomb's law वापरून पॉइंट चार्ज मुळे जो फोर्स क्रिएट होतो तो कॅल्क्युलेट करणं इझी आहे कुठल्याही टेस्ट पॉइंटला किंवा टेस्ट चार्जवरचा. पण जर लाईन चार्ज असेल किंवा सरफेस चार्ज असेल किंवा व्हॉल्यूम चार्ज असेल तर त्या केसमध्ये ते फोर्स कसा कॅल्क्युलेट करायचा, ठीक आहे, हा प्रश्न आहे आपल्या समोर. तर आपल्याला 3 स्टेप्स माहित आहेत ज्या आपण पॉइंट चार्ज साठी अप्लाय केल्या होत्या. ड्रॉ नीट स्केच, फाइंड आउट द वेक्टर, युनिट वेक्टर अँड मॅग्निट्यूड, अँड लास्टली यूज द कुलोम्ब्स लॉ. आपल्याला त्या 3 स्टेप्स माहित आहेत. आपण थोड्याशा त्या स्टेप्स चेंज करायच्या आता. अवघड काहीच नाही, खूप सोपं आहे. जसं सांगतोय मी आता, चार्ज कॉन्फिगरेशन्स. नाउ वी आर अंडरस्टँडिंग चार्ज configurations. And जसे या चार्ज कॉन्फिगरेशन्स मी आता सांगतोय, इट विल बी ऍप्लिकेबल एव्हरीवेअर इन इलेक्ट्रोमॅग्नेटिक्स, राईट. जे चार्ज कॉन्फिगरेशन्स असतात हेच असतात, लाईन चार्ज, सरफेस चार्ज किंवा व्हॉल्यूम चार्ज. जसं आपण पहिल्या युनिटमध्ये म्हटलेलं की लाईन चार्ज असेल तर तुम्ही सिंगल इंटिग्रेशन घ्यायचं, सरफेस चार्ज असेल तर त्याला डबल इंटिग्रेशन, आणि व्हॉल्यूम चार्ज असेल तर त्याला ट्रिपल इंटिग्रेशन घ्यायचं. दॅट्स इट. दॅट इज हाऊ वी आर गोइंग टू find out the values, find out the force or electric field intensity, or let it be anything. So in previous problem, just now atta jo apan problem bagitla, in that problem we have learned ki how we can compute the force due to a single point charge, right? So that point charge is not necessarily be always a point charge. तो लाईन चार्ज सुद्धा असू शकतो किंवा सरफेस चार्ज पण असू शकतो किंवा व्हॉल्यूम चार्ज सुद्धा असू शकतो. सो लेट मी राईट हियर फर्स्ट हेडिंग लाईन चार्ज. लाईन चार्ज, जर तो लाईन चार्ज असेल तर तुम्ही काय करणार, राईट? So this configuration is formed when charge is uniformly distributed over a line. हे चार्ज लाईन कॉन्फिगरेशन, लाईन चार्ज कधी तयार होतं तर जे चार्जेस आहेत ते जर युनिफॉर्मली डिस्ट्रीब्यूट केले असतील एखाद्या लाईन वरती, देन वी विल कॉल इट एज ए लाईन चार्ज. सो सिन्स दिस चार्ज इज युनिफॉर्मली डिस्ट्रीब्यूटेड, चार्ज डेन्सिटी इज द charge per unit length. Now here what I'm writing here, first of all let me draw the line charge. I will divide the screen into 3 parts. Okay. So what I'm having is a line charge. So this is the line, and on which let me draw the charges. Charges I will draw with the red color. So these are the uniformly distributed charges. So all those charge will have their own electric field around that charge, and we are trying to find the electric field, or you can say we are trying to find the force at this point. We are trying to find the force at some random point. We will call it as a test charge, right? So let's assume this is test point or QT, and this is the line charge, right? So because of this line charge, how much force is created at this test charge? This is what our topic of discussion. This is a test charge. Now, as I said, there exists a charge density. That charge density I am going to define now. मराठीमध्ये डेन्सिटीला काय म्हणता येईल? त्या चार्जची घनता. सो चार्ज डेन्सिटी. चार्ज डेन्सिटी किती असणार आहे? जसं मी आता त्याचं डेफिनेशन सांगितली. डेफिनेशन ऑफ चार्ज डेन्सिटी फॉर लाईन चार्ज, इट वुड बी लाईन चार्ज डेन्सिटी. So let me add one word here, line charge density. Line charge density is defined as, can someone tell? It's a charge per unit length. It is charge per unit length. So mathematically, let me write here charge density. We have notation rho L. Rho L is denoted as this line charge density is denoted by rho L, and it is equal to, now I am writing the formula for this, total charge spread, जसं आता आपण पहिल्या एक्झाम्पल्स मध्ये बघितलं, चार्ज स्प्रेड जर असेल तर त्याची व्हॅल्यू दिलेली असते, लेंथ ऑफ द लाईन डिवायडेड बाय लेंथ ऑफ द लाईन. So if I say it would be a charge divided by length of line, what is the unit of this rho L? What is the unit of line charge density? Charge unit काय असतं? सांगा पटकन. What is the unit of charge?
Coulomb.
Correct. And the unit of length? Meter.
Meter or centimeter.
So for this rho L, unit is coulombs per meter. Right? आता एवढं केल्यानंतर आपला प्रॉब्लेम सॉल्व्ह होतोय का? नाही होत आहे. आपल्याला काय करायचंय, या लाईन चार्ज मुळे क्यूटी टेस्ट चार्ज वरती तयार होणारा फोर्स कॅल्क्युलेट करायचा आहे. पण आपल्याला कुलोम्स लॉ वापरता येतो, पण इथं काय करणार, जिथं ही कंप्लीट लाईन दिलेली आहे, तर त्या केसमध्ये तुम्ही या लाईनचा छोटासा पार्ट सिलेक्ट करायचा, टोटल लाईनचा छोटासा पार्ट सिलेक्ट करायचा, लाईक दिस. ठीक आहे. सो दिस पार्ट वुड बी कन्सिडर्ड ॲज डीएल, म्हणजे छोटासा म्हणजे किती, डीएल डिफरन्शियल, आणि हा पार्ट म्हणजे तुमचा डीक्यू म्हणून ऍक्ट होईल. डीक्यू म्हणजे हा स्वतः एक छोटा पॉइंट चार्ज असल्यासारखा ऍक्ट होईल. ठीक आहे. Rho L is the line charge density of this. आता मला सांगा, जर तुम्हाला डीक्यू माहित असेल, डीक्यू फाइंड आउट केला उदाहरणार्थ, हा डीक्यू जो आहे तो स्वतः एक पॉइंट चार्ज म्हणून ऍक्ट होईल. ठीक आहे. तर तुम्ही काय कराल, जर फोर्स कॅल्क्युलेट करायचा झाला तर डीक्यू, सो दॅट वुड बी डिफरन्शियल फोर्स. दिस वुड बी डिफरन्शियल फोर्स डीएफ. It is equal to dq into qt divided by 4 pi epsilon naught r square a bar r. समजतंय? म्हणजेच काय, हे जे काय असेल ते डिस्टन्स असेल r. दिस डिस्टन्स इज r. मी काय केलं, डिफरन्शियल फोर्स काढला, म्हणजे हा फोर्स काय असणार आहे, फक्त या छोट्या डीक्यू मुळे जे काही फोर्स क्रिएट होतोय टेस्ट चार्ज वरती, तो फोर्स काढला, त्याला म्हटलं डिफरन्शियल फोर्स. आणि हा डिफरन्शियल फोर्स भेटल्यानंतर तुम्ही टोटल फोर्स कॅल्क्युलेट करू शकता. टोटल फोर्स एफ बार इज इक्वल टू, जसं मी म्हटलं लाईन इंटिग्रेशन, लाईन चार्ज असेल तर त्याला सिंगल इंटिग्रेशन करायचं, सिंगल इंटिग्रेशन ऑफ डीएफ बार. आणि ही डीएफ बार ची लिमिट्स काय असतील, इनिशियल टू फायनल, म्हणजे ह्या टोटल लाईनची लेंथ असेल, ओव्हर दॅट लेंथ यू हॅव टू इंटिग्रेट इट टू ऑब्टेन द टोटल फोर्स. समजताय? जर पॉइंट चार्ज मुळे फोर्स क्रिएट झालेला तुम्हाला काढायचं असेल तर तुम्ही डायरेक्ट कुलोम्स लॉ वापरू शकता. पण लाईन चार्ज मुळे किती फोर्स होतोय, किती फोर्स येतोय तो कॅल्क्युलेट करायचा असेल तर डायरेक्ट कुलोम्स लॉ वापरता नाही येणार. तुम्हाला त्याचा छोटासा सेगमेंट सिलेक्ट करायचा डीएल, जसा मी इथं सिलेक्ट केलेला आहे. दिस इज डीएल. You have to select a small segment called as DL. This is called as differential length, which can be treated as DQ. A small, or you can say small segment of that line कॅन बी ट्रीटेड ॲज अ पॉइंट चार्ज. आता तुम्ही याला पॉइंट चार्ज म्हणताय म्हटल्यावरती तुम्ही कुलोम्स लॉ वापरू शकता. कुलोम्स लॉ वापरून तुम्ही काय कॅल्क्युलेट करणार, हे डीएफ बार का म्हटलंय, कारण ते डिफरन्शियल असणार आहे. आपण छोट्याशा पॉइंट चार्जमुळे जो काही फोर्स क्रिएट होतोय तो कॅल्क्युलेट केलाय, म्हणून त्याला म्हटलं आपण डीएफ. आणि जर टोटल या लाईन चार्जमुळे टोटल जर फोर्स कॅल्क्युलेट करायचा असेल, that you can calculate by integrating it. You have to integrate that over that a complete line. So this is what concept of line charge is. I hope you understand this. जसं आपण example solve करायला लागू, you will understand it a little bit more. So let me proceed further for surface charge. So surface charge configuration. आता इथं जे चार्ज कॉन्फिगरेशन आहे ते ना की पॉइंट चार्ज आहे, ना की line charge. You are having a surface. So this is the surface. Surface means two-dimensional picture I can draw. You are having a test point here. You are having test charge here. So the charge, or you can say the charges, are uniformly distributed over this surface. Right? In that case, one more density would be there, that is called as a surface charge density. That is called as a surface charge density, which is denoted by, it is denoted by rho s, denoted by rho s. And this surface charge density is defined as total charge spread, total charge spread divided by, can someone tell? Divided by, बघा इकडं लेंथ ऑफ लाईन होता, इथं सरफेस साठी काय येईल?
area.
Correct, absolutely correct. Area of the surface. So what would be the unit of this? Coulombs per meter square, because unit of charge is Coulomb, unit of area is meter square, right? So this would be the unit of surface charge density. Now here, if I try to find the same problem, same solution for the problem, like if I want to find the force, total force on QT because of this surface charge rho s, then what you will do, you have to select a small segment of this surface, let us call it as ds, and you can treat this ds as dq. You can treat this as dq. So here in this case, dq is equal to rho s ds. dq is equal to rho s ds. Additionally, I am writing this formula. dq is equal to rho s ds. In earlier case, I can write in the similar way. What I can write? dq is equal to rho l dl. In this case, what I can write? dq is equal to rho l dq is equal to rho s ds, right? Yes. Now from that you can come to know that dq, value of dq. Now how you can proceed further? So you can find df. df is a differential force created by dq, which is equal to dq qt upon 4 pi epsilon naught r square a bar r. I hope you understand this term. कंप्लीट सरफेस मुळे तुम्हाला फोर्स कॅल्क्युलेट नाही करता येणार, त्यातला छोटासा सेगमेंट घ्या, त्याच्यामुळे फोर्स, डिफरन्शियल फोर्स म्हणजे डीएफ कॅल्क्युलेट करा, आणि एकदा तुम्हाला डीएफ मिळाला की तुम्ही टोटल फोर्स काढू शकताय त्याला इंटिग्रेट करून. आता या केसमध्ये इट वुड बी अ डबल इंटिग्रेशन. आय टोल्ड यू दिस. It would be double integration for the case of surface integral. df bar, right? So this is the way in which you can calculate the force due to a surface. Force due to a surface. Similarly, we can proceed further to understand the volume charge. Right, so here let me write here third charge configuration. This is second, this is first. So third charge configuration is volume charge. So for volume charge, what I can do, okay, let me draw a cylinder. Okay, let us assume this is a cylinder. Right, and inside this cylinder the charge is uniformly spread, uniformly distributed. Yeah, so this is the charge uniformly distributed all over the cylinder, right? And you are having a test charge somewhere here, and you want to find the total force acting on this test charge qt. Right, so in that case what you can do is you can select a small volume of that cylinder, right? So we will call it as dv. This dv can be considered as, it can be treated as dq, means small point charge, and find out the force because of this dv or dq, right? So this way you can proceed further, but here also we are having another terminology called as a volume charge density. Volume charge density. So what would be the notation? It would be rho v. But I'm trying to tell this by using some analogies. Here you are having line charge density rho L. Notation is rho L. Here we are having surface charge density. Notation is rho S. Here we are having volume charge density. Notation is rho V. So can someone tell me what is rho V? Rho V is equal to charge in the volume, charge in the volume, total charge you can consider, total charge in the volume divided by volume, total volume of that cylinder. So what would be the unit of this? Coulombs per cubic meter. Coulombs per meter cube. Right? And what about dq? If I consider this dq, it is equal to rho s dv.